Wanted to make a quick video on Newton's law and working with the equation, and then just some unit stuff as well. So the equation that they give you on Edgenuity is F equals m times a. This is the force, this is the mass, and this is where they're going to try to throw you off. The mass has to be in kilograms, so I'm going to go over that as well, how to convert grams to milligrams. They're going to give you some numbers in grams, but before you do this equation, it has to be converted into kilograms. And then the acceleration is meters per second squared. They don't have to do anything with that. They put it in meters per second squared for you. If you don't know why it's meters per second squared for acceleration, you can go back in Google Classroom, and I've got a video on that as well. So I'm going to show you how to use this equation. I'm going to put off to the side here that triangle that I went over with you before, and I'm going to use this as a reference. So F goes on top, mass, acceleration, okay, and I'm going to show you how to kind of work with that, because you're going to need this for some of the, especially the lab. So I'm just going to come up with some easy numbers to work with. Let's say, and this is what we would have done in class, I would have shown you how to kind of work through these problems to make them a little bit more organized. So the first thing I'm going to do is I'm going to make a list of the three, actually I'm not going to do that, for the three variables that we're working with, force, mass, acceleration. So I'm just going to work with mass first, and I'm going to make this like they would try to throw you off. So let's say I've got 23.5 grams, and honestly I'm saying that they would throw you off, but we'd be doing this in class. If you're measuring something in class with a triple beam balance, you're going to get it in grams, but then during the lab you're going to need to convert it into kilograms to use the equation. So I'm saying they're trying to throw you off, but really we would be doing this in class. It would just be more I don't know, organic, because we're actually using the triple beam balances to find the masses. But let's say I've got an acceleration of, I don't know, 8.3 meters per second squared, and we need to find the force. So that's pretty simple. If I want to find the force, it's mass times acceleration. So I write the equation that I'm going to be working with. And you can try to skip steps on this, but there's really no way around it. You have to work this out, or you're just not going to get the right answer. When I'm making labs for you guys, I actually do this process because, well, I can't be wrong when I'm explaining it, and honestly, you can't be wrong either. So, you know, this process really works. You write a list. You write the equation that you need based on the triangle, and you just fill it in. So the mass I've got, it's in grams. I need to convert it into kilograms. To do that, you need to move this decimal over 3 places to the left. And I don't know if you remember this or not. And actually, if you want to write this down, I'm going to put this down at the bottom. We worked with this last year. Meters, liters, grams are the basic units. And then moving to the right, we've got deci, which is D. This is probably looking somewhat familiar. Centi, which is C. And then milli, which is M. If it's M all by itself, it's meter. But if it's MM, it's millimeter. Okay, so it has, in order to tell if you're here or not, if you've got 2 units, 2 M's together, it's millimeter. Working in this direction, you've got deca, which is dk. And again, this should be review from last year. Hecto, which is H, and then kilo, which is K. Okay, so I've got 23.5 grams. That puts me here. Okay, I need to get to here to work with the force equation. So I'm going to go 1, 2, 3 jumps to the left. So I've got my 23.5. 1, 2, 3. I put a decimal. I put an egg in the cup. And there we go. Okay, so right there I've got 0.0235 kilograms and times 8.3 meters per second squared. Okay, to work this out, I mean, if you want to pause it and write this down, that'd be great. But I need to erase it to finish my problem. So here we go. So force equals, they do have a calculator on Edgenuity. So, you know, you can use that. I'm more of a handheld guy when it comes to calculators, just makes it a little bit easier for me. But 0.0235 times 8.3. So I've got, and I'm going to write the units and then I'm going to explain the Newton thing. So I've got 0.20 because, let me zoom in real quick. Okay, sometimes they usually have you measure to the nearest hundredth or 2 decimal places. So it's 0.195, which is going to round this up to 0.20. Okay, so you got to pay attention to that from your math class. How do you round numbers up and down? Okay, so this would be 0.20. I'm going to write the units out. It's kilogram times meters per second squared. That is the answer. Like, oops, sorry. Let me back that up. Sorry. Okay. This is the actual unit. No one wants to look at that unit. That is an ugly unit. So they're going to name it after the guy who came up with all this stuff, who was Newton. So when you see a Newton, this is the actual unit. Okay? So, which later on you're going to be working with. Okay? Sometimes you have to take a Newton, make it into this. So this is what a Newton is. But that's that. So the abbreviation would be 0.20 N. Okay, and that would be the answer. Okay, now I'm going to work with this thing right here. Oops, sorry. Back that up a little bit more. There we go. Okay, now I'm going to work with this. So I'm going to, because sometimes they'll give you the mass and the force, and you got to solve for acceleration. Sometimes they give you the force and the acceleration. You got to solve for mass, right? And that's where this thing comes in. Okay, so let's say I've got a force of, ooh, here we go. Let's actually work with what I just explained to you. So let's say they give you a force of 23.2 newtons. Okay, let's say they give you the acceleration too, but we don't know what the mass is. Okay, let's say the acceleration is I don't know, 12.2 meters per second squared. Okay, so we need to solve for mass. So what you do, take your finger, mass, it's force divided by acceleration. So mass equals force divided by acceleration. Now watch how this works. Mass equals force, which is 23.2 newtons. But we're not going to use the N. We're going to use the meters, kilogram meters per second squared. So I'm going to rewrite the Newton as the actual unit. Okay, and you can kilogram meters per second squared equals N. That's what a Newton is. So I'm going to write that down. So 23.2 kilogram meters per second squared divided by 12.2 meters per second. Okay, and then if you notice, right, anything on top of itself cancels out. So meters per second squared cancels, which leaves me with kilograms, which is a mass, which is what I want. So 23.2 divided by 12.2 equals 1.90. So mass equals 1.90 kilograms, because that is the only unit left, and it's a mass, which is what we want. So that is the answer. Okay, so I'll go the other way. Okay, so let's say they give me a force and a mass, and they want me to solve for acceleration. So say my force is 8.6 newtons. They're going to give it to you in newtons. And let's say the mass is, here we go. Let's say the mass is, I don't know, 45.1 grams. Can't use grams, got to be kilograms. Okay, so the first thing you got to do is convert that into kilograms. So 3 places to the left, 0.0451 kilograms, right? Because here, I'll show you down here. 45.1 grams equals. Got my little bouncy ball here, the decimal. 1, 2, 3. Put an egg in the cup. Okay, so it's 0.0451. So that's that. Okay, so that is the number we're going to use. Okay, so in order to solve for acceleration, I need force divided by mass. So I write my equation. Acceleration equals force divided by mass. Okay, and then I'm ready to work. So force, again, we're going to use, instead of newtons, we're going to use this unit right here. Okay, so force, 8.6 kilogram meters per second squared, divided by, got to use this one, you have to use kilograms, 0.0451 kilograms. And anything on top of it self-cancels out, so the kilograms cancels out, which leaves me with an acceleration unit, which is what I want. Acceleration equals, simple division problem, 8.6 divided by 0.0451 is 190.69. They probably will have you do it to the 10th with a number that big, but no, I'll just do it. 190 point, I'm going to say 7. 10th is fine. 0.7 meters per second squared is the only unit left. And that's it, sir. Okay. So that's how you work with the Newton's second law, which is this. Okay, force equals mass times acceleration. But again, it can be rearranged to solve for mass, acceleration, or force. And also, this is what a Newton unit actually looks like. Any questions about it, let me know. This is going to be especially helpful during the lab, which I'll be explaining to you on Friday. Okay, take care, everybody.